So thank you for coming, and thank you for the organizer. This is the first year here in FOSDEM, and I'm very happy about that. So today we are going to speak about how to debug and trace a RabbitMQ node. I will show some things, some RabbitMQ internals. Please don't try this at home, or better, don't try this in production. This is just to understand how powerful can be the Erlang tracing and debugging. So they already said about me. I'm currently working on RabbitMQ in Kubernetes. Forget to say that you can win this puppet today. I will ask some complex question. If you will answer correctly, you can win one of these. Just naming for the people that don't know anything about RabbitMQ, Erlang, etc. Do you know RabbitMQ? Raise your hand. Lot of people. Do you use RabbitMQ in production? Is there someone that does not use RabbitMQ? You deserve this one. And the win. As you can see, it's extremely hard to win. There is another one, so be attention. So RabbitMQ is a message broker. The interesting part for this talk is that it's writing in Erlang and the command line in Elixir, starting from RabbitMQ 3.7. A node is just running Erlang and Elixir application. The beam is the Erlang virtual machine. So let's start speaking about analyzing a Linux machine or a server. What you usually do is to connect remotely in the server, analyze the processes, analyze the memory, kill some process if need. Maybe the process is using a lot of memory, a lot of CPU, and you want to just kill it and restart it, and run your script inside the server. So what if I say that you can do the same with an Erlang application? So the remote connection in Erlang is called Erlang Remote Shell. There are several tools inside the beam, like top, that is called, usually there is an a top, a prof, etc., inside the Erlang virtual machine. There are several tools to manage, to trace the memory, to understand what's going on inside the beam memory, and you can execute a custom code inside the node. And one of the most interesting feature, I think, that is that you can load dynamically the code inside one beam. Even if the code is, even if the beam is remote, you can load or you can send code to the virtual machine. I usually use this kind of the feature when I have to work, for example, inside Kubernetes, because in Kubernetes maybe I have to test some Kubernetes API, and I don't have all the Kubernetes local, and I have to test it remotely. And this is one of the best feature, I think, from my personal opinion. So I will show you a demo live, because I am brave and I like to show some things live. Here I have a RabbitMQ node running. That is this one. Can you see it? All right. The host name is RabbitMQ Leap. My host name is Leap because I just don't. I spent almost 1 hour to decide the host name of my machine, and I give the default one. I don't have fantasy. And we will use the observer tool. We will access inside the RabbitMQ database configuration, because for the people that use RabbitMQ, I think that if you want to look inside the RabbitMQ database, it is extremely hard to look inside the database. And we will call an internal function, we will trace it, and we will load a custom module. So let me, okay, let's try this. So the first one is that we are going to we are going to access to the remote RabbitMQ node. As you can see here, the local node, my local node is called debug, but I can call the local node as you prefer. Can you see it, guys? That's better? Okay. And here now I am inside the RabbitMQ node. It's easy, as you can see, too much easy. So the first tool that someone I think that no is observer, no this one, well this one. So the first tool is the observer that gives you an overview in what's happening inside your virtual machine. The number of cores, the memory, you can check, for example, the memory utilization, I/O, etc., etc. This is the processes that you can order based on the memory usage or the number of the reduction, PID, etc., etc. The interesting thing here is this one. When you go to inside table view, you can analyze the ATS table and the Mnesia tables. RabbitMQ uses Mnesia only for the configuration. This is a common mistake that someone thinks that RabbitMQ uses Mnesia to store the messages. RabbitMQ uses Mnesia only for the configuration. Okay, in this way you can see what there is inside the database. And maybe you have some problem with some queue and you want to check if the queue actually exists or stuff like that. Please don't touch the database, just view the database. You shouldn't never touch directly this database, but if you want to try it, maybe just to break it, you can do that. So it's easy because a RabbitMQ is enough to delete the varlib Mnesia, varlib RabbitMQ, and you recreate RabbitMQ recreates from scratch everything. Another the problem with the observer is that it requires the graphics library, and for example, when you have a remote server in Kubernetes, you don't have the graphics library. This is useful, especially when you work locally. There is another tool that is called Observer CLI. That is, let me try to do that. Can you see it? Okay, this is exactly the same for observer, but it's just using command line, so you don't have any problem with custom libraries and you don't have to install anything. Again, this is another great way to analyze the RabbitMQ node, but you can install this in your Erlang or Elixir application if you want. You should. You must. Okay, so now let's try to call some internal function inside RabbitMQ, and let's see how to trace it. Let's suppose that I want to create, for some strange reason, an queue. Oh. Too much, excuse me. Okay, so this function RabbitMQ blah 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 declare etc etc. This is the internal code, the internal RabbitMQ code to create one queue. So we just created one queue using the internal code. You don't trust me, right? No, eh? This one. Okay? You trust me now? Okay, so let me check the time. I still have time. Okay, so now that, let's suppose that you want to trace a specific code inside RabbitMQ, but this is in general. If you want to trace one call in your beam, it's enough to start dbc At the moment, I don't want to spend too much time on DBC because it requires another kind of the session, but just to let you know that you can just start the DBC, and this is the pattern, that's the call that I want to trace, that is declared with all the parameters, and this is the, I want to trace only the call, the function calls. Now let's try again to create another queue. Let's call it, for example, 3. Here, as you can see, there is the full stack. The first one and the second one, and the return function. Everything you can do, everything live, so the RabbitMQ node is still up and running with the second queue, okay? Don't forget to stop, oops. Don't forget to stop the DBC, especially if you are trying to trace a production node, because the DBC is not totally free. If you are inside, for example, a loop or some complex function, the DBC can use a lot of memory, a lot of CPU, etc., etc. Now we are tracing the call using the console, but you can use file. That it's better. You can use TCP socket, stuff like that. Now we can do some things more complex here. That is some things like that. Okay, this one, for example. Let me. I just created 100 queues. Okay, the timer break. 100 queues inside using always the same function, but just using a loop. Okay, but when you start to work using console, it's a bit hard because okay, you can write function, but start to be extremely complex when you want to do some things more complex. So this is what I want to show you. I have here this Erlang file. Okay, that is inside my local machine. Excuse me. Okay. Okay, it's enough to add the path and load the module. Now we have just added a new module inside RabbitMQ, a custom module inside RabbitMQ with a running node. I think that this is extremely cool. Now say hello. The beam is very cool. Do you agree? Yeah. Who was the first one? That one. Yes. Cool. Okay, so in this way you can, as I said, add or remove code, etc., etc. So again, be careful for what you want to add in your system. You can also remove and delete the module when you have finished it. Or if you want, you can write your own custom plugin inside RabbitMQ. Why not? Okay. Another thing, when I say that you can do what you want, is some things like that. So you can also stop RabbitMQ and done. So that's, and you can start again in this way. Okay, I don't have the queues anymore because I created the temporary queues. So for the people that know RabbitMQ, when you stop and restart RabbitMQ with a temporary queue, you don't have the queues anymore. So when you have finished basically with your trace, debug, and stuff like that, is enough to just kill the node and it's done. Last note: you should use the hidden parameters. That is, when you use this command hidden, okay, thank you. you will connect to a RabbitMQ or another node, and your node will be not listened in the node's code. That this should be the right way to do that. Now, I have only 5 minutes. As I said, I worked recently to one new feature in RabbitMQ Kubernetes plugin, and I had to use a lot because I didn't have the Kubernetes in local, and I couldn't try this function in local, so this was the best way to work. After that, I copy and paste the function, and it worked. So, security. Someone is thinking, I think, that, oh my God, everyone can access on my module at this time. So don't panic, because in order to access a remote shell, you need to have the port mapping port open, and you need the Erlang cookie. Erlang cookie is a sort of secret that you shouldn't share with other people, and it's enough to just to enable the firewall. And speaking about RabbitMQ, is enough to open the MQP port. And you should use the remote access only inside Trust Network. Don't try this in production. For example, if you want to play with RabbitMQ, you can do that. But in order to create the queues and exchange, you should use the standard API, because there are several controls around queue creation and exchange creation. So play with it, but when you are in production, be careful. You have to know what you are doing in production. So I just have more or less a couple of minutes. I finished it, but I want to point out some things that is extremely important for me, and I think that the Italians guy, they will agree with me. Because when I go around, I see strange things marked as Italian dishes. I want to point out that spaghetti alla bolognese does not exist. I am from Bologna, and trust me, it does not exist. The second one, spaghetti con polpette, does not exist, because it's, kids. It's, yeah, okay. Fettuccine linguini Alfredo does not exist. The question is, who is Alfredo? Because we don't know Alfredo. Do you know Alfredo? No, we don't know. Another thing is that the linguini does not exist. It's not an Italian word. Okay? Linguini, maybe linguine, but linguini does not exist. And the last one, Italian cappuccino, only for breakfast, please. Not after lunch, not, please, guys. Thank you. So, a few links that can be useful to trace, and these are external tools that you can use, and if you want to just play with it. If you have questions about food, wine, etc., feel free to ask, and I finish. Thank you. Of course, if you have questions about RabbitMQ and body stuff. Yeah.
We've spoken a lot about food already, so I will skip the food part.
All right.
But I know you're working a lot on Kubernetes right now, and
yeah.
I wanted to know if all that you have shown right now will still work in the context of a container, and most of all, if you ever experimented with the distroless containers, which is one of the things I'm working on the most right now. And
yeah.
I'm kind of interested in how this whole Erlang shell plays with the distroless containers.
I didn't test it. I usually use the standard. Okay, if I can use the remote shell in the distroless containers. So I didn't test it. But I think that it should work. I don't see any reason why it shouldn't work, because Erlang, it creates its own virtual machine, the port mapping, and it shouldn't work, but it's a test that I'd like to do. I usually use the standard RabbitMQ image and work up the standard RabbitMQ image. This is because I don't want to create another standard, This is another standard. I think that, from my experience, the creation of a new node is enough fast. So why you want to use this distroless? Is there any reason? All right. So, but speaking about Kubernetes in general, I didn't have any special kind of the problem. The problem is only to accessing Kubernetes. Once you are inside, I didn't have any problem. Questions?
Are there any like word production stories that you'd like to share, like some debugging?
So let me say, if I have some story about debugging, etc. Let me say that I spend more time debugging RabbitMQ than write code. Yeah, yeah. For example, there were a bug in the garbage collector, because for the people that work with the garbage collector, the first thing is, oh, garbage collector is very cool because I don't have to destroy the memory, etc., etc. After a couple of months, how can I call how can I force the garbage collector call? So I have to find the issue, but basically there was a problem with the garbage collector, and we introduced parameters that each X function the garbage collector is forced to call. And I spent time with tools that is called eprof Erlang, this one. That is a timing profiling for Erlang. So you decide to trace one specific call, and you can see which function is called most, and you can decide. In this case was the garbage collector, because the garbage collector was inside the function for some reason, and we decide to call it each, I don't know, X number of the number of the reductions. Other stories is mostly about Kubernetes, and yes, another one interesting is that I found a bug in LazyQ. Do you know LazyQ in RabbitMQ? No? LazyQ is a kind of the queue. I found a bug when you switch from the normal to lazy, and using the DBC but logging in file, because it was very high stack. Using the DBC, I could find the problem, and I could resolve the problem. Just was hard, but I could resolve the problem analyzing the trace. Okay.
Thank you.
Thank you.